This is a video about intersecting chords. Now, a chord is, if I just draw a circle, anything that goes through or touches a circle at 2 points. So that would be a chord there. Another type of chord might be this one. Now, this one here, if it goes through the center O, is a special type of chord, and that would be called a diameter, whereas this one here is just a normal chord there. The two rules we're going to be looking at today are both to do with intersecting chords. Now, this first rule here says that if we have the lines AB and CD, and if they cross at X, there is a rule that determines their length. So we can say that the length of AX times by BX will equal CX times by DX. So once you know this rule, you can use this to actually work out the different sides if there's one missing. So say, for example, this one was 10 and this one here was 12, and say this length here was 6, and we didn't know what that length was. So essentially what we do is we know that 10 times by the 12, so 10 times by 12 will equal 6 times the x here. Okay, 6 times the x. So we can just solve this. 120 is equal to 6x, therefore x is equal to 120 divided by 6, so x would be 20. Of course, this is not to scale. And let's have a look at the next rule here. This is when you have the chords, but they actually go outside of the circle here. Now, it's the same sort of principle, but here we go, let me go through the rule. The rule is that AX times by BX will equal to CX times by DX. So actually it is the same rule as the previous one, except it just depends on where you place your A's and B's. So be careful, it's the full length here of AX times by the BX. So this is this entire length here times by this small length here will equal the entire length here times by this small length there, which are these two here. So imagine we knew that this length here was, say, 5, and this length 6, this one here 4, and this one could be x. Now, this is where it gets a little bit more complicated because it's the full length of AX, okay, the full length of AX, which would be 4 plus 5, which is 9, and that would be times by the short length, which is the BX, times by 5, will be the same as the full length CX, which is 6 plus x, and that will all be times by the length DX, which is 6 there. So we can say that 45 is the same as 36 plus 6x, because I've multiplied both this by the 6 and this by the 6. Now it's possible to just solve this. So 45 minus the 36 will equal to 6x. So we know that 9 is the same as 6x, therefore x will be 9 over 6, which is 3 over 2, or x is 1.5 for this question. Now, say, for example, we're looking at these two questions here. If we've got, so remember that AX times by BX will equal to CX times by DX. So we know that AX is 3 and BX is 8, and that will equal to CX, which is 6, times by DX, which is x in this case. So we know 3 times 8 is 24 is equal to 6 times something. If we divide both sides by 6, we find that x is equal to 4 in this case. But how about this question here where they're intersecting outside? Again, we know that this entire length here, AX, okay, which will be 2 plus the 4 is 6, times by this short length there, which is 4, will be the same as this entire length here, okay, which will be 3 plus x, and that will be times by this short length here, which is 3. So we know that 24 is equal to 3 lots of 3 plus x. So 24 is equal to 9 plus 3x. We can take 9 away from both sides. So 24 minus 9 is 15. 15 is equal to 3x. Divide both sides by 3. x will be equal to 5 in this case.